Okay, so like I said, we're going to review trig functions today and tomorrow. Our goal for today is to cover radian measure and sinusoidal graphs. Sinusoidal graphs are the waves that we have for sine and cosine, and then the other waves we have for tangent, cotangent, secant, and cosecant. So what do you need to know? Are we expecting perfection on your waves? No. Do they have to look reasonable? Yes. Okay. All right, so here we go. We are agreeing as a class, radian mode in this class. Okay, unless specifically specified with a degree symbol, but pretty much everything is going to be in radian mode. Okay, keep your calculator in radian mode. Huge. Okay, what is a radian? A radian is a segment of the outer edge arc of a circle. So 1 full radian all the way around is going to be 2 pi. And then whatever fraction of that you represent is the radian of, if you're only going quarter of the way, then it's a quarter of the 2 pi, and then you work out the math accordingly. Angles are always measured from the x-axis, and then they go up. So please keep in mind, we're always going this direction for positive angles. If we say a negative angle, then you're going to go down through quadrant 4 and around, okay? Always spinning in a counterclockwise manner. All right, so quick review from trig on how to convert from radians to degrees or degrees back to radians. So if I start you out with pi ninths in radians and I ask you to give me the equivalent in degrees, what do you do? Okay, so you're thinking multiplying by like a conversion factor. Sure, okay, that's great. I also will use like a cross multiplication, and that would be fine. But if we want to put this into degrees, which however way you want to do that. So I always think of the radians to degrees, what the equivalent is. If the radians are pi, the degrees have to be 180. That's the relationship. So you're either multiplying by pi over 180, or you're multiplying by 180 over pi, okay? And so what Carla is saying is she wants the pi to go away. She needs pi to be, we need to take it out of the radian conversion. And so she's saying her multiplication is going to be to multiply by 180, and she's going to put the pi in the bottom. So you either use that fraction with the 180 in the top or the 180 in the bottom to your advantage. And so when you multiply then, we can reduce, and we also reduce the pi's. So what are we left with? How much? 20. And that specifically needs to have a degree symbol on it to show that you've converted it. Okay, if we're going the other way, so if I ask you to convert 37 degrees, then you're going to multiply by the pi on the top and the 180 in the bottom. And then that there's not reducible because 37 is a prime number. So we end up with 37 pi over 180, but there's no degree sign anymore because this is not in degrees anymore. This is in radians. All right, so that's just a quick review. That should be easy. Okay, graphs. These are the graphs I expect you to be able to picture in your head. If I say cosine, you instantly picture a wave that touches at 1. Okay, that is key about cosine. That cosine's wave starts at the number 1. For calculus, that's really going to be an important number that you picture that. For sine, it's going to be key that you picture the wave where that goes to the origin. Okay, those two distinguish. Okay, amplitude is one thing, that's how high and low it gets in the period we'll talk about, but the starting points are going to be really important. For these, they have a period calculation. For both of them, it's 2 pi divided by whatever number b is in the problem. We'll talk about where you get b in just a minute. Okay, period is 2 pi over b. A tangent graph also goes through the origin, which will be important for you to know. Tangent is one of our famous odd graphs. It's odd because if you look at quadrant 1 and quadrant 3, they are exact opposite mirrors of each other. O opposite odd origin. all those things with O. Its period is calculated differently. It's only 1 pi over b. Tangent has asymptotes. You're expected to draw at least 2 asymptotes, one on either side of the origin. You don't have to draw all of them, but at least one on either side. In the module, there is where you got your graph paper. There's also a trig graph paper, and that will be helpful for you. It gives you a nice axis for trig. All right, here we have secant and cosecant. Notice that secant also starts at the number 1, just like cosine did. Those two are cousins. Okay, they're reciprocals of each other, and so they both start at the number 1. Period's still 2 pi over b. Cosecant does not start at 0 because the reciprocal of 0 doesn't exist. So the cosecant has an asymptote right away, right down the y-axis. So for these, you need 3 asymptotes for cosecant and 2 asymptotes for secant. You just need to be symmetric. You need to have 1 asymptote on either side of the y-axis. So for cosecant, the middle one is the y-axis, so that one doesn't count. I mean, you got to draw it, but it doesn't count. So you want 1 on either side to keep it symmetrical. And then for secant, you want 1 on either side also. Cotangent has an asymptote right down the center. Also, its period is 1 pi over b. And again, you're going to have on either side of the y-axis. So you've got one of them going on the y-axis and then something on either side. Okay, that's a quick overview. We're going to do some sample problems for the rest of class now. Yeah, no. Uh-huh. Oh, what did I put? I put 0. I don't know. I was probably saying something and I forgot. Yeah, it's B. Thanks. Okay. All right, here you go. This is how you want your trig to look. You know how we were working with, and Andre asked the question, and a couple other people, like about the order that you do shifts in, Isaac too, and how the parentheses should go and how that it should all look. If you can organize your trig equation in this order, and then you just do everything in order, and it works out great. So if you have an A out in the very front, that's called the amplitude, and that impacts the height of the wave. It also impacts the height of the space in between a secant and a cosecant graph, because in between a secant and a cosecant graph is supposed to fit a wave. There's a wave that fits right in the middle of that. If you remember, okay, in between here is an invisible, it's got to fit. Its corresponding cosecant graph or its corresponding sine graph has to fit. So if the amplitude is bigger, then the space between the secant and cosecant is going to be bigger as well. And then, Andre, to go back to what you asked earlier, if there is a negative in front, that's a reflection over the x-axis. Okay, if there's a negative anywhere else, not in front, it will be a reflection over the y-axis. Okay, this F can be anything. It can be sine, cosine, secant, cosecant, tangent, cotangent. It can be any of the 6. All the rules are the same. Here's your B value. Notice what is separating B from X. What's between B and X right now? A parentheses. The B should be separate from the X. Okay, factoring it out. Otherwise, you're going to get your shift wrong. If you don't factor, you'll still get the period right, but you'll get your shift wrong. And then we've got a horizontal shift, which is the minus C, and then any vertical up and down shift is going to be the plus D. But factoring out this B right here will be important to getting the shift correct. So let me show you one here. This is what I mean. Figure out the period, domain, range, and sketch the graph. So let's figure out the period, domain, and range. Well, let's identify this first. There's a reflection. It's going to reflect over the x-axis. Okay, here is the amplitude. One thing sometimes people will get wrong, especially on a multiple choice, they'll tell me that the amplitude is -2. The amplitude is never a negative number. The negative is the reflection part of it. The 2 is the amplitude. The amplitude is still 2. even if it's negative, it's reflected, but it still has an amplitude of 2. Okay, the 4 has not been factored out of this problem. So we're going to have to do a little bit of work. And to factor is the same thing as to divide. So you divide. So this question becomes -2 sine parentheses 4 separated from x. That's how we're factoring that out. Plus pi fourths. Now we can correctly see what the shift is. Previously, we may have thought the shift was pi to the left, whereas in reality, the shift is pi fourths to the left, which is a big difference. Really impacts how your shift goes. Okay, and then we want period. We can get our period from the 4 here. So our period is going to be 2 pi divided by the number 4, which is half pi. That's our period, or pi over 2. I don't mind how you write it, either way. And then what would the domain and what would the range be? Domain questions are still the same. Does it have a denominator? No. Does it have a square root? No. Does it have a logarithm? No. Therefore, the domain is all real numbers. The range has to do with the graph. We can anticipate that the graph is going to follow the wave pattern with an amplitude of 2. Therefore, the amplitude would go down to negative, or the curve would go down to -2 and up to +2 and down to -2. And so our range would be -2 to +2. And if you want to write that with brackets, you can. So then let's practice how we would graph that. Okay, so on your next slide, this is the graph paper that I have in the module for you. It's just a single axis. It's a nice long axis to the right, so you have enough room. Okay, this is how I suggest you draw your graphs. Draw first, label later. One of the mistakes I see people make is that they try and label their graph first and then try and make their graph all fit within the labels. Draw your graph first. This is what I mean. Okay, a good graph is separated by about 4 tick marks, 4 scale marks. That's a nicely spaced graph. My graph needs to go down to 2. So I'm going to go down to 2 and then come up. And then my graph is going to do the same thing. Then I label my graph. After I've drawn one good cycle, then I label it. Okay, my label is going to be 0 where it started, -2 and +2 are my amplitude. I already know from the previous slide what the period is. The period should be 1/2 pi. That's the end of the period. So if that's 1/2 pi, then my center should be 1/4 pi. So I basically am looking for 5 dots. I'm looking for the origin, the middle, and the end. And then I'm looking for your low and your high. Those 5 dots should be about in the right place. Draw it first. So all my graphs are going to look the same, but all my scales are going to look different. And then I shift this left 1/4 pi. So left 1/4 pi is going to be out here. This is where -1/4 pi is. So I'm going to grab my graph. And I'm going to slide the whole thing. If I was in Notability, I could. Okay, I'll do it in a different color. So my final graph ends up down here. And those 5 dots. So really, I'm just looking for 5 dot spots. Okay. Any questions on that? Andre?
Did you say you wanted the original function as well?
You do not. Sometimes it's helpful to have it sketched there in a, but you don't have to keep it. Okay, here's another one. Here's cosine. Again, my cosine is not factored correctly. So we would want to factor this. So we want to divide by 1/2. That means I get 2 cosine 1/2 factored away from x plus. And when you divide pi by half, you get 2 pi. Okay, so then I would draw 5 dots for this. Remember where cosine starts. Cosine has to start at the amplitude. So I'm going to get 5 dots like this. There's 4. Just take a look at it a minute. Do you see where my 4 dots are so far? I could put my dot number 5 up here, but those are harder to draw, I feel like. So instead, I put my last dot over here. Now I've got 5 of them. What kind of graph does that look like? Does it look like cosine to you, or does it look like something else? Kind of looks like sine. How do I know it's actually a cosine? I know it's a cosine because of that, because of where it is. So it's up to you. You could keep going over here. Okay, I don't mind. This is what I am cautioning you against. If you put your 5th dot, this is the last thing I'll show you. If you put your 5th dot here, what do you think the temptation is to make your graph end up looking like when the dots are arranged that way? It ends up looking like a V, and it really should not be a V. So just make sure that you curve it and curve it so we for sure know that the ends are going back down, that it's not a V, that it is graphed like that. So now we're ready to label our graph and put our scale on there. And so since we know that the amplitude is 2, then we've got 0, 2, and -2. And then the period, we got to figure that out a minute. So we're going to use the number 1/2. So our period would be 2 pi divided by half, and that period turns out to be 4 pi. So then we're going to go back and label the 4 pi, the end of the period, should be right here. So here's 4 pi, which means that 2 pi is the center, and that 1 pi and 3 pi are the other values we've got going along. So my graph now reflects the scale of the right amplitude and the right period. Okay, then we're going to shift to the left 2 pi of a value, and so to the left of 2 pi, kind of thinking, all right, well, to the right of 2 pi was this far, so then to the left of 2 pi is going to be moving it that far. So all my values need to move over to the left. So I'll have all my dots that are forming this cosine curve going to move 2 pi to the left. So my final curve is going to look like this, and just be real sensitive to the fact that you are for sure making it look like a cosine where the ends are pointing down. Finally, we would state what the domain and the range are. So the domain is all real numbers, and the range, looking at what the amplitude is, we're looking at -2 to +2. Okay, let's do a quick tangent. So again, I would recommend drawing before you work on labeling. So a graph for tangent automatically is going to have 2 asymptotes. So I would suggest putting your asymptotes right on there right away. And then the graph for tangent is going to come up through the origin, and our graph is going to look like this. All right, and then so that's our sketch. So now we go through, all right, we want to reflect. And then we're going to need to do some shifts and some labeling. We need to figure out the period. All right, so we can reflect this graph. So as we reflect it, we can take this off. And our reflection is going to look like this. Okay, there's our graph. Sorry, I should not be touching my asymptotes. My asymptotes are kind of thick. And then we want to label what we've got going on here. All right, so this is where we got to use the 1/3 to figure out our period. So our period is pi divided by b. So that's pi divided by 1/3, which is 3 pi. Okay, now the period for tangent is equally spaced between the asymptotes. So 3 pi has to be the total space from one asymptote to the other. And so one of my asymptotes is going to be 3/2 pi, and the other is going to be negative 3/2 pi, okay, or 3 pi over 2. It's not 3 pi and negative 3 pi, okay, it's half on each so that the total on either side is 3 pi. Okay, then the only shift we have is a shift up of 1, and so we're moving this up 1, so my shift then comes down and my graph is going to look like this. All right, so let's talk domain and range. My domain does have what's considered a denominator. And you might be looking at that going, I don't see a denominator, but it's in how tangent itself is defined. Tangent is sine over cosine. So there is an implicit denominator in there, and the denominator is what's producing all of our asymptotes. And so our asymptotes are happening at positive 3/2 and at negative 3/2. And so the way we say that is like this. We say it's all real numbers, but x can't be, it can't be 3/2 because that's where the first asymptote is. And the space between all the asymptotes is 3 pi. So it can't be plus or minus 3 pi because that would bring me to another asymptote. And it can't be another 3 pi after that or another 3 pi because every time we have another cycle of 3 pi added to that, we're going to have another asymptote. So to indicate the repetition, we multiply that by k. So that's kind of a complicated domain, but it's all real. What it means is all real numbers not equal to where the position of the first asymptote is, and then plus or minus any cycle of the period after that. The range is a lot easier. It's negative infinity to positive infinity, because, or you can put all real numbers for the range because it goes infinitely high and infinitely low. Okay, and then for this one, looking at a computer-generated graph, could you figure out what the amplitude in the period is? So let's look at maybe this one first, this gentle one. Okay, it is a sine graph because it's going through the origin, and we want to know what its amplitude and period are. So we use the scale to help us out. We know that the scale is negative 5 by 5. And so that means this is 5 here and negative 5. So if we count backwards, 5, 4, 3, 2, 1, 0. And so it looks like the graph is crossing right near the number 3. And in trig, we know that there's a number pretty close to 3. That's a famous number in trigonometry, and that probably is the number pi. And so this is likely crossing close to pi. So the first asymptote, the first x-intercept would be at pi. So then we could hypothesize that if we extended this graph a little bit, it would come out and probably cross a little bit beyond 6, which would be at 2 pi. So that tells us what the period is, that the period from the origin through to one full cycle, that period is going to be 2 pi. All right, the amplitude of this graph, again, if we look at the scale 4 to negative 4, so we're at 4, 3, 2, 1, and so it looks like the amplitude is 1. Okay, let's take a look at the other graph, which has a much shorter period. The cycles are happening much more quickly, and so we're looking at, let me see if I can highlight it for us. What color should I do? I'll just do green again. So if we're going to do this graph here, okay, one cycle is hitting between the number 1 and 2. And so something a little bit on the closer side to 2. And so using kind of our inference of what values are, that's going to be pi over 2. So it's helpful to be thinking, okay, we know that something that was a little bit more than 3-ish, that was pi, and something that's about 1.7-ish, that's half pi. Okay, it's exactly half, and that's what that is intended to be. And so one cycle for that one completed within a period of half pi. And then the amplitude on that is going to be 2. So you're using decimals and inferences and probably a little bit of logic to help with especially these numbers, okay? So we know that pi is exactly equal to 3.1416. And so this would be, you know, closer to 1.57. Okay, so 1.6-ish. All right, so I hope you have some success with this lesson tonight. So please use the trig graph paper that's provided in the modules, and that will just give you some good scales and good things to draw on.